In today's video, we're going to be talking about describing motion. After watching this video, you should be able to know the difference between distance and displacement and understand what the difference is between speed, velocity, and acceleration. So let's get right into it. So we're heading into a unit of physics called mechanics, and kinematics is kind of a component of mechanics, and basically it's the science of describing motion of objects. So kinematics is all about movement, and the way we describe motion of objects is through words, diagrams, numbers, graphs, and equations. Okay, so kinematics, like I said, is a part of mechanics, it's a branch of mechanics, and basically it's all about motion, and we're going to use a variety of methods of going about learning kinematics. So the first thing we need to talk about is something called a scalar and something called a vector. And these are two terms you really want to become familiar with. A scalar is a quantity that is described only by a magnitude or a numerical value alone, and that's it. Okay, so just I guess a preview of what's to come, speed is going to be a scalar. If I tell you I'm going 30 miles per hour, that would be telling you my magnitude of my speed. Okay, I'm traveling 30 miles in 1 hour, but you have no idea what direction I'm going. I could be headed to Chicago, I could be going to Milwaukee, I could be headed out west, but all you know is I'm traveling 30 miles per hour. A vector is a quantity that describes both a magnitude, so a numerical value, and a direction. So to make a vector out of speed, we call that velocity, and that has a direction associated with it. So I could be saying I'm traveling 30 miles per hour east. Okay, and now that's considered a vector. Okay, so two different terms, scalars and vectors. So distance and displacement, two words that both start with D, but there's a difference between them. Distance is a scalar quantity, and that just basically refers to how much ground an object has covered during its motion. Okay, so how much ground have you gone over? Whereas displacement is actually a vector quantity, and it refers to how out of place an object is. It's the overall change in position. And I have a picture in just a second that will kind of help explain these two concepts. But distance is scalar and displacement is a vector. And it kind of turns out in physics, we typically focus more on this thing called displacement. Okay, so because we're always interested in what direction things are going. So here's a good example of the difference between displacement and distance. All right, if I were to say, take my dog for a walk. Okay, here I am. Okay, I'm going to take a walk with my dog. I'm going to go around this square. Okay, I wish I could draw better. So I take a walk, I go around this square, and so I walk up 2 meters, to the right 4 meters, down 2 meters, and then left 4 meters. So what is my total distance that I covered? How much ground did I cover? And the total distance would be 2 plus 4 plus 2 plus 4. And so if you do that, that should be 12 meters. Okay, so I walked 12 meters. That's great. Now my displacement, once I'm back to where I started, how much did I actually change my position? From this starting point, how much did I actually change my position? And if you're thinking 0, you're correct. I actually didn't displace myself at all because I'm back to where I started. Okay, so that is the big difference between distance and displacement. Displacement is how out of how far away from the original spot are you, whereas distance is actually talking about how much ground you covered. Two other terms that show up quite a bit in physics is speed and velocity. Speed is something that we use in everyday life. You know, I got a speeding ticket, or watching videos that say Need for Speed. All these things, that's a term that's common, whereas people don't say, hey, your velocity is a little high in the car. You know, like maybe your parents are yelling at you because you're driving too fast. Okay, so speed is probably the more common term, but it is a scalar quantity. Okay, it is a scalar quantity, and so it just refers to how fast an object is moving. So speed can be thought of as a rate at which an object covers distance. Now notice we have no idea what direction that object is actually moving, but we just know that it's moving at some rate. Okay? Velocity, on the other hand, is a vector quantity. Okay, a vector quantity, and that refers to the rate at which an object changes its position. Okay, so how much displacement has occurred. Okay, so we're going to see those words, distance and displacement, probably in the formulas for both speed and velocity. Okay, so we're going to see how we use those differently. And here they are. Wow, it's like I almost made these slides. So how do you calculate speed and velocity? Speed is the distance traveled divided by the time. Okay, so speed is distance divided by time. Notice distance is not a vector quantity, that's a scalar, and so that's why speed also is a scalar quantity. Whereas the velocity, or the average velocity, is the change in the position. And if you ever see that triangle, that just stands for change. Okay, so the change in the position divided by time, which change in position really is displacement. Okay, how much did you displace yourself from the starting point, and how long did it take till you finally got to the ending point? Okay, so two different things, but yet similar. Okay, so they're similar but different, if that makes sense. All right, acceleration. This is the one that I think people get messed up on the most, and I'll do some picture drawing in just a second. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. I should have probably underlined that, but I'm going to underline it right now. Changes its velocity. When I think of acceleration, I want you guys to think of change in velocity. Oh, good, I underlined it here. Wow, I just need to read the rest of my own slide. An object is accelerating if it is changing its velocity. So if I'm telling you I'm going 10 meters per second to the right, and that's all I'm doing, I'm not accelerating. Okay, I haven't changed my velocity at all. But if I tell you that I'm going 10 meters per second to the right, and 2 seconds later now I'm going 14 meters per second to the right, I now had to have accelerated. Okay, so this is the formula for acceleration. It's the triangle, which stands for change, the change in velocity divided by time. Another way of writing that is your v final, that's what this stands for, v, and then there's a little f under there that stands for final, so the ending velocity, if you will, minus vi, which stands for v initial, over time. Okay, so if we go back to my example, let's say I start moving to the right at 10 meters per second, okay, and I end moving to the right at 14 meters per second, and let's say this takes me, we'll say 2 seconds to do this. Okay, so if I were to calculate what is my acceleration, well, I would take my ending time, which is 14, minus my starting time, which is 10, divided by how long did it take me to do that? 2 seconds, right? So 14 minus 10 is 4 over 2, and that would be 2 meters per second squared. Meters per second squared are the units for acceleration, and that would be my acceleration. I basically am speeding up by 2 meters per second every second, or 2 meters per second every second. Okay. Where this gets confusing is objects that slow down are also actually accelerating, and that seems counterintuitive because in everyday life we don't say, hey, will you accelerate? And if you hear that, you think to yourself, well, I should go faster. But maybe your parents would start, if you're driving too fast, I know when my kids drive, I'm going to say, hey, start accelerating. And that will mean to them, slow down, you're going too fast. Okay, so acceleration can mean speed up. It can also mean slow down. All it's about is changing the velocity. If you change that velocity, you're accelerating. Okay, so here's just kind of an example of velocity and acceleration. All right, so let's say I have a car here, and again, I wish I was a good artist, so you're going to see all these skills. It's a square car. It's the new model that's coming out. If it's going 10 meters per second to the right, and then let's say at this point it's going 14 meters per second, and again going to the right, and at this point it's going 18 meters per second. What can you say about this car? Well, hopefully you're realizing that this car actually is accelerating. The car is accelerating. How do I know it's accelerating? Its velocity is changing. Okay, so it has a velocity is changing. Let me write that down. And I'm actually going to write yes, accelerating. Okay, just so we can know. Now let's say I have a car here that's at rest, and it starts to move, and at this point it's going 5 meters, I can't write, 5 meters per second, and let's say at this ending point it's going 2 meters per second. Okay, is this car accelerating? And we would say, yes, it is. How do we know it's accelerating? Well, it started at rest and it got up to 5 meters per second. And then a little time later, it was going 2 meters per second. Even though it slowed down here, yes, I know it slowed down, that still is called an acceleration because the velocity is changing. So yes, it's accelerating, okay? And the reason why is because the velocity is changing. Now, last example, let's say this car is going 5 meters per second here. And then here it's going 5 meters per second. And then here it's going 5 meters per second. Is this car accelerating? The answer is no, it's not accelerating, and it's because the velocity is staying constant. Okay, it's staying the same. I could draw a fourth picture and just have a car sitting here doing nothing, not moving at all. It also would not be accelerating. Okay, so that gives you hopefully a little bit of a ground work for kind of what's to come, talking about distance, displacement, velocity, and acceleration, all terms that you really need to know to be successful in physics. I will see you guys in the next video. Take care.